All right, so welcome to the lab session for this week, and in this lab session short video, I'm just going to go over the basics of ROS, right? So in the lecture earlier this week, accompanying this lab session, we went over a beginner's introduction to ROS, and I want to show you some of those very important commands that you will work with as you develop your understanding of ROS. And so this is meant to be one of many lab sessions that we will go through together. And in fact, there is a handout which is accompanying this lab session. It's available on the course web page. I'll include the link in the description of the video as well, so you can follow along with that handout. I'm not going to follow exactly the sequence in the handout. This is a bit of a impromptu lab session, but we'll try to cover everything in the handout, and especially everything which I consider important as the first ever lab session in ROS itself. So as you can see, I've already booted up my Ubuntu 18.04 Bionic instance and opened up a terminal session. You'll have to get used to doing this a lot. And then if you followed the instructions shared earlier to install ROS Melodic on your distribution, one very quick way to verify that it's correctly installed is to just print out the environment variables in your distribution, and then we are piping the output of this print environment command to only echo things which begin or contain this phrase ROS. And so when we run this, you should see an output something like this. We won't go over what each of these environment variables represent, but as you can probably tell, it's telling you, where ROS is installed. If you remember, you even had to source this directory as one of the steps in the installation process. We'll get to the ROS master more in a little bit, but you can see there's something called ROS master underscore URI, and I'll explain later what URI stands for. As you would notice, as also stated in ROS Melodic, it still uses the Python version 2. So Novatec uses version 3, but this particular uses version 2, and you did install all the Python dependencies as part of the installation process. So this is just a very quick check, to make sure everything in your ROS installation is intact and nothing has broken down. All right, so let's maybe start with our very first ROS command that, if you recall from the lecture slides, to begin launching ROS, or to begin using ROS and interact with all the ROS nodes, all the packages, you have to start ROS by typing in the command ROS core, right? So when you execute this command, you will see a bunch of different messages. So let me tell you what's going on. So when you start ROS core, what it does is it launches the ROS master, which is what we also discussed in our lecture. So as you can see, it's starting the process called master with some process ID. And then it's also doing a few more things, right? So it's starting something which is called a parameter server. And parameter server, you can think of it as, this is the workspace server, or the part of ROS which is going to store the values of all the variables and the parameters of the different nodes and what have you. And so we'll get into parameter server as its own brief little tutorial later when we jump into some other concepts of ROS as well. So the first thing is ROS master, second is the parameter server, and the third thing, which is also started when we start ROS core, is like a ROS out logging node, right? So it's starting this service or this node called ROS out. I know it's a node because it begins with this sort of a backslash symbol before the name, and you'll see how nodes are typically represented with this symbol in front. And so this is just a logging node, which is used for debugging purposes. It's going to log the activity of, what nodes am I launching, what topics are they exchanging, and things like that. And these are kind of event-driven logs that you can, if something crashes, go back and figure out, what happened. So you have to do this always, right? So the first thing you do is start raw score, and we will leave this session as is, right? So this is now running our raw score process. So to do anything else, we have to launch a different window. And so here I will launch my first node. And remember, the format to launch a node is you say Ros run, name of the package, and name of the node. So let's launch this node together. We can say Ros run. My bad. We can say Ros run. Name of the package is Turtlesim, and name of the node is Turtlesim _ node. By the way, just to be clear, if Ros is installed, you can just hit tab and it should autocomplete many of these command line arguments, and because it knows where things are located. Anyways, that's for a different discussion. So here is our first node. The package name is Turtlesim, and I'm trying to launch a node in this package that I already know it is part of this package. And so let's see what happens, right? So when we run this, we get this Turtlesim simulator. So here is already your first hint, why every distribution comes with its own turtle. It has to do with this inbuilt learning tool, or inbuilt very simple simulator but still very effective way to learn ROS, and the simulator is called Turtlesim. That's why every ROS distribution has its own turtle design in both the logo of the distribution and in Turtlesim as well. All right, so let's take a look at what was echoed when we launched. It says I'm starting Turtlesim with the node name Turtlesim. So again, see, the node name has this slash in front of it, and then it says I'm spawning a turtle. The turtle is called Turtle1 at these coordinates and with this pose in the ocean, right? So to describe the position of this turtle, it's telling me the XY position with the bottom left as the origin of this ocean, and theta is the orientation, which is along the x-axis. Therefore, it's 0 in this case. So let me move this turtle here and make some space for other nodes that I want. And it's a good idea sometimes to always keep this turtle on top, especially because the Ros node window is just running by itself in the background. So now we have done something, right? We just launched our first node. So let's create another terminal, open another terminal session. And this one we will use to understand what is going on with this node that we just launched. And it will also be used to understand a few more ROS commands. So one of the things that you should get used to, in this case, we just launched a node, but in general, the way to understand which nodes are running in your system is a very simple command, and that's Ros Node List. So this will list out all the nodes which are currently running in ROS. This one is the one that we just launched, and ROS out is the one which is started by itself when you start ROS code. So we get used to this command of Ros Node List. And since we only have one interesting node to inspect, you can learn more about this node by saying Ros Node Info followed by the name of the node. And again, I just typed TUR, hit tab, and since there was only one node which auto-completes, in this case, Ros will do that for me. I don't have to type or mistype the names of these nodes. So when we run Ros Node Info, we get a bunch of different outputs. So let me expand this. Yeah. So here's the output. A lot of things have been shown to us about Turtlesim, and that's the command Ros Node Info. Already you can get a sense for the intuitive part of ROS, right? So to list out, I just say the list of ROS nodes, so Ros Node List, and to interact with a particular node, I say Ros Node Info, name of the node. So very, very intuitive. And we will see the same kind of philosophy extend to topics and messages as well. So you could say things like Ros Topic List, Ros Topic Info, and so on. So let's look at what information we are getting about Turtlesim right now. So it's telling me that the node's name is Turtlesim. I already knew that, but it's, that's part of the info as well. And importantly, it's telling me that Turtlesim is publishing on these topics. Okay, so Turtlesim is publishing a bunch of different topics. If we ignore the logging message, there is something called Turtle1 color sensor. This is a name of a topic on which some messages are being published by Turtlesim. In fact, this is the topic name, and in the parenthesis, the square brackets, we see the name of the message type. So remember that topics are channels on which messages are sent, and messages are data structures, right? So the type of message accepted or compatible with this topic called color sensor is of the form Turtlesim color, and we'll get into the weeds a little bit of what these message data structures exactly are. Then the important thing is it's also publishing something called Turtle1 pose, right? So the pose is the name of the topic on which we just saw what is the pose of the turtle. It is the position and the heading of the turtle collectively. And so in robotics, the single term to describe both the position and heading of a robot is called the pose of the robot. And therefore, this is like a robot swimming in a virtual ocean. So its pose is published on this topic called Turtle1 pose, and the message type of this pose is Turtlesim / pose with a capital P. So this is case sensitive, and you need to pay attention to what is uppercase and lowercase. So these are the publications of our Turtlesim simulator, and we'll inspect these in just a second. But let's continue down the info that was echoed by Ros. So the next thing to see is that Turtlesim is also subscribing to another topic, and this topic is called Turtle1 / command velocity. So this is the short for command velocity. And notice how that the message type of command velocity is unknown. That is because there is no publisher yet in the system who is publishing on this topic. So this node has no way of knowing what kind of messages will be sent on command velocity until at least one message has been sent. And since you only have a single node running right now, there is no node publishing on this topic, even though this node is currently subscribing to this topic. All right, so as you can see, this is already an example where a single node can both publish and subscribe to different topics in the same node. The next thing that draws your attention is something called a list of different services, and I won't go into explaining what services are right now because we haven't covered that in our lectures. But in a nutshell, services allow you to manipulate the turtle or perform different operations on the Turtlesim node. So for example, just reading it out loud, reset probably means that if the turtle moves, and we'll move the turtle by the end of the lab session, you can reset it to its home position or default position, or you can spawn a turtle at a particular position. And similarly, other services that we will use and understand, and they'll be part of your assignment sessions as well. You will use things like teleport absolute and teleport relative. So in a nutshell, this is what the Turtlesim node does, and our command to interact with the Turtlesim node was to look at Ros Node Info. So we've learned two commands. We have learned three commands actually. We have learned how to launch a node using Ros run, package name, node name, and then we have learned to list out all the nodes and to learn more about any particular node. All right, so I hope that is clear. So let's jump into topics now, right? So similar to nodes, you can inspect what are the different topics in the system. So we can say Ros Topic List. And again, we already knew this information from a previous interaction, but I'm just using this example, and it will seem repetitive to show you these different commands. And that's why we'll only work with the one node for now, and then then things will very quickly become very interesting as we start publishing and interacting with the turtle. So we already know that there are 3 topics in the system, and we just saw that 2 of these are ones which are being published by Turtlesim, and one of them is being subscribed by Turtlesim. It doesn't have its own publisher. So we have these 3 topics, and let's say just like we did Ros Node Info Turtlesim, you can use Ros Topic Info in this case, and then we can inspect in more detail attributes of a particular topic that we are interested in. So since we know, I think, most about pose right now, so I can just say turtle and then hit tab, and I'm going to say pose. I want to learn more about this topic, turtle1 pose. And so Ros tells me that the message type, so the type means the message type or the typecast, the message type of the messages which are allowed to be published on this topic, turtle1 pose, are of the form turtlesim / pose with the capital P. Then it says the publisher of this topic is Turtlesim. We already knew that from our previous inspection of Turtlesim itself, and nobody yet is subscribing to this topic, right? So imagine this node graph where Turtlesim is a node. It is broadcasting a topic called turtle1 pose with the message type capital P, pose with the capital P. And so it's publishing that, but nobody yet is subscribing. Why is nobody subscribing? Because there is no other node that we have launched yet that would be potentially interested in or has some use of this pose information. So just like Ros Node Info, you have Ros Topic Info as well, and there's other Ros Topic commands as well. Sometimes you don't need this verbose output a whole lot. You just want to know, maybe like you run Ros Topic List, you see the name of the topic, and then you just want to know what is the message type of the topic. So you can say something like Ros Topic type, and then the name of the topic that you want the message to, right? So it will just give you this precise information rather than all this other stuff about who's subscribing and who's publishing as well. So that's a good way to look at the message type. Now we have we have looked at the node, we have looked at the topic, we know the message type, but maybe I want to go even further. I want to see the message data structure to understand how pose is represented in form of different fields of this data structure in Ros. So this leads us to the next set of commands which deal with messages, right? So we know commands that launch nodes, we know commands which interact with nodes, we know commands, a few of them, that interact with topics. Now let's go into a command which interacts with messages, right? So here I can say something like Ros message. This is a new command. Show. So show me the message type, and I know the name of the message is this, right? The output of the previous command, or the type of the message type listed in when we looked at the full output of the info. But so remember, messages don't begin with the backslash over here, right? So we can just type in Turtlesim, and I know the name of the message type is pose. So when I say Ros message show, Ros message show is similar to saying Ros message info, and we hit enter, and so now it shows me the exact fields of the data structure which comprise of the pose message type. And already you can see there's something interesting going on, right? So earlier we thought that pose is only X, Y, and heading, but in Turtlesim, it also contains the velocity information of the turtle. So right now the turtle is not moving. Both of these values would be 0, and I'll show you in a second how do you actually read the pose out. But the point I want to make here is the order of things in which we proceeded, right? So we looked at the list of the different topics in the system, and we could repeat this for any of the other topics as well. For total one pose, I first just inspected what is this topic. Tell me about who's publishing, who's subscribing. Nobody is subscribing. Turtlesim is publishing its pose out, and then we say, well, what is the message type of this topic? The message type is Turtlesim pose with a capital P, and then similar to the Ros Topic list of commands to interact and with the different topics, we looked at another command which is Ros Message to now show me the message type itself, the data structure itself, so that I have a better understanding of this. So to show you how this is being used, let me actually show the real-time messages that Turtlesim is publishing. And so for that, we will use a command which will be used very often when you work with Ros, and that is Ros Topic Echo. So you want to echo the messages from a certain topic. So I want to read the post that Turtlesim is publishing. So the name of the topic where the post is being published is this one right here, right? The one that we just interacted with. So I will say Ros Topic Echo total 1, and this time pose with a small p, because this is the topic name, not the message. And when I hit enter, you can see I get a bunch of different messages. These are continuously being published, and because they are the same message, they are not scrolling as you would imagine. When things are actually changing, you can see the values also change. But as we expect that the X and the Y position is exactly where the turtle was spawned when we launched Turtlesim, right? So we launched Turtlesim, and it was spawned in the center of the ocean with theta 0, and currently it has a linear velocity of 0 and an angular velocity of 0 as well. Okay, so let me clear this out, and the point was that you use Ros Topic Echo to actually see messages on any topic. And the topic of interest right now for us was Turtle 1 pose, so we use that as an example. All right, so now let's look at how to actually move this turtle. And for that, I will refresh your memory again by saying Ros Node Info. Let's say Ros Node Info, and the name of the node is Turtlesim. And so we just saw this a while ago. The thing that I want to draw your attention to now is this topic right here. So Turtlesim is subscribing to a topic called command velocity, which sounds like something that can be used to move the total amount, because it's like a velocity command. And so that's what we will try to explore next. Can we publish something on this topic that will be subscribed to by Turtlesim, which it already is being subscribed to by Turtlesim, and therefore the turtle will respond to these commands. So how do we go about figuring that out, right? So let's jump into that. The first thing I may want to do is I want to inspect. So let me just list out the different topics again. I want to inspect more, just like we did for pose. This time I want to inspect and understand more about this topic called command velocity. So for that, what I can do, I can say Ros Topic type. I want to understand the message type first, and this time I want total 1 command velocity. So it uses a message of type geometry underscore messages / twist with a capital T. Okay, so that's just the name of the message. Let me now look at the actual data structure of the message. So if we say Ros message show, and I want to learn about geometry messages twist. And so now all of a sudden I know that the topic command velocity uses some message types called geometry message twist, and each twist message is using this definition of the message data structure. So it has something called a linear velocity and an angular velocity, and each of these in turn has three components. So you can say, I want you to move linearly with this velocity on the x, y. Z doesn't make sense here because the linear velocity along z doesn't make sense. The angular velocity of z can be thought of as a rotation around the axis which is coming towards you from the ocean, right? So each of the linear and angular velocities has three components, and that's what the command velocity geometry twist message is. By the way, you may be wondering, why has a message type been declared which has redundant things like linear velocity along z? The important thing is that geometry messages are a general type of messages of the form, that this twist message is a general type of geometric message. And Turtlesim is just reusing that structure, but when something publishes a geometry message, it will read and only use the fields which apply to or make sense in the ocean, right? So we've taken a look at the geometry messages slash capital twist message type. So now what I want to do is I want to use this information that we have learned about the command velocity and its a message type called geometry message twist, and I want to use this to try and publish some data on the command velocity topic. And then because Turtlesim is subscribing to that topic, I want to see if whatever we publish will manifest in some sort of a movement of the Turtlesim node. So let me show this first, and then I'll explain what is going on. So I will use the command Ros Topic Publish pub. I will give it a publishing rate. I'll explain this in a bit. The name of the topic I want to publish on is Turtle1 command velocity. The message type associated with this topic is geometry message twist. You can see how I just hit tab, and Ros is able to automatically fill that out. And now I can hit tab again, and it's automatically kind of populating what it expects as the arguments. So let's give it some values here. I want to say move along the x direction with some velocity, and I also want to let's say rotate it with some or maybe that's too fast, with some angular velocity. And so now if I run this, you can see that it published this message once and our turtle just moved, right? So that's pretty cool. We got our turtle to move just by publishing some message. So what's happening underneath the hood, right? So what we have done is we have used a command called Ros Topic Publish. We have specified the rate. So this means just you need to publish one message. And I have used this information about the name of the topic, the message type, and the data structure. And then Ros has helped me out by just auto-completing stuff when I hit tab. And all I had to do is just give it the inputs of the data, right? So this geometry message has two vectors of 3 floating point elements. So each of them, the linear and the angular. In this case, the 2, 0, 0 is the linear value, with x component of the linear being 2 and y and z being 0. And the 0, 0 and 1.8 is the angular value with only the non-zero z component. And just as a aside, we'll get into this in the course. These arguments are in what are called the YAML syntax, and so that's why they have this particular format. And what you have noticed is that the turtle stopped moving because in order to continue to move the turtle, it requires a steady stream of command velocities, right? At some steady rate. But what we did was we only gave it a particular argument where even if you look at this line, it says I'm publishing and latching the message for 3 seconds. This is another way of saying that I'm just publishing it once, right? So I'm not continuously publishing the stream of command velocities, but we can even fix that. We can publish a steady stream of command velocities using the Ros topic publish and then an argument called -r, where we can use that -r argument to continuously move the turtle. So let me show you that what I mean by that. Let me clear the shell first, and although I said we will look at services later, here is an example of using a service. So I'm going to use, oh, I misspelled. So Ros service, I will say Ros service call. And one of the services, remember, that Turtlesim was offering was called reset. So we'll use that, and you can see the turtle has been reset in the ocean, right? And we can see that here as well. And so that's how you use services, by the way. I know, like I promised, there's be a dedicated lecture on service, but right now this was the fastest way for me to kind of clear the ocean and reset the turtle rather than close all these sessions and relaunch them. Anyways, that gave us a chance to look at how you use services with this command Ros service call. But the point I want to do, I want to make is this time we will publish again on this command velocity topic, but we'll try to continuously publish, right? So let's do exactly what we did before. We can say Ros topic publish, and then I will say I want to publish to turtle1 command velocity. The message type is geometry message twist, and here I will say first that I want to publish at a rate, so I specify an argument r of 1, and then I can say the message I want to publish. So here I'm going to say I want to publish this message to 0, let me say 2.0, 0.0, and 0.0. So that's the linear component, and then we can specify 0, 0, and I think I used 1.8, and that's the angular component. So this is the same interaction as before, with one change, that I have used the argument called -r followed by the rate at which I want it to publish. Okay, it's giving me an error. Maybe I need a space here. Oh, okay. I think I need a space here. Yeah. So this is the outcome of a continuous publication of the command velocity. And so, instead of the previous part where we just published this once, now there's a stream of command velocities. Each of the message of command velocity is this format. And by the way, I know this is different from what I just did previously, where I hit tab and it showed me the structure and I edited it. But this is, accepting the same. It's accepting the same YAML format of the linear and the angular parts. So I just wanted to show an alternate way. And as you can see, even I made a mistake. You need to be careful about the spaces and the syntax when you use this brief way. So maybe it's better to stick with the verbose way, where you hit tab, it will show you the different components and you just fill them. So this is great. So our turtle is moving, and now let's actually go back and look at the pose and echo the pose of the turtle, right? So now I want to revisit one of the commands, which was Ros topic echo. So maybe I should refresh your memory first. Let's just do Ros topic list. So we still have the same things. Nothing has changed. We didn't introduce any new topics. But now let's look at what messages are being published by Turtlesim on its own pose. So remember earlier this was a static message because the turtle was not moving. But now you can see that it says that the linear velocity with which the turtle is moving is 2 and the angular velocity is 1.8 and the position or the pose of the turtle is continuously changing. Right, so this makes sense now, I hope, that you can echo the messages on the terminal session. And then the other thing I want to show is we can even echo the command velocity itself. So we can say turtle1, can you show me what is being now published to command velocity, because we are just publishing using this Ros Topic Publish command. So here you can say every message of the command velocity is exactly this message with 200 and 001.8. So I hope things are starting to make sense, that we had one node which was subscribing to command velocity and publishing its pose, and now all of a sudden we have created this dummy publisher. This is not a node, right? So this is not a Ros node. I mean, that's not correct. So this is creating a node underneath the hood, and maybe I should show you that too. So if I make some space and let's revisit Rosnode List. So see what is happening, right? Earlier we just had a Turtlesim and a logging node, but now there is a new node called Ros Topic with some pseudo-random number sequence appended to the name. And this is actually this session, right? So this terminal execution process right here. Because this Ros Topic Publish has internally created some node with some random name, and that node is now publishing to Turtlesim. Right, so and to convince you of that, you can even say Ros Node Info, and let's look at Turtlesim first. And if you recall, earlier it was saying that the message type of this command velocity was unknown. But now, since it has started receiving some messages on command velocity through this random node, it knows that the message type of command velocity is of the type geometry message twist. So all the pieces of it are kind of coming together. Right? So this is how you interact with Turtlesim in this kind of a using this Ros Topic Publish. It's obviously not a straightforward manner. It's not like the preferred way to interact with Turtlesim. So I will show you a better way and a slightly different way. I do want to first show you another thing, and that's a new argument to one of the commands that you already know, which is Ros Topic Hertz. So we can say Ros Topic and Hertz. So I want to inspect the rate at which something is being published. So I will say turtle1 and command velocity. So you can see that it's telling me that the average rate at which command velocity messages are being published is 1 Hertz. So where did this value 1 come from? This is where we specified that argument, -R1. So indeed, this is what we expected, that we want at a rate of 1 message per second to be sent to Turtlesim. And similarly, if you want, you can exit that. By the way, if you're curious to exit, I've just pressed Control-C or Command-C, and then that will end the execution of this node, because these echo nodes, they will continue to otherwise run. And so we can repeat the same. We can say Ros Topic Hertz, but this time I want to look at how often is the pose being published. And so you can say the pose is published at a rate of around 60 Hertz. So much higher than the command velocity. But you can use the Hertz argument for Ros Topic to learn about the rate at which things are getting published, because sometimes that's important. You need to know how often you will get data or how often will something receive data. All right, so I can still let it run and show you a bunch of new things. So let me first show you how do you use one of the tools in Ros. And one of the tools in Ros is called RQT plot or RQT graph. So let me show you first. Ros run, let's say RQT graph and RQT graph. And let me move the turtle to show you the graph. So RQT graph is a way to look at a visual computation node graph in Ros, right? And without even me having to explain, if you followed along the tutorial, I think this should already make a lot of sense. What this is telling me is, and I'm right now just showing nodes only. They are let's say that we want to see everything, or maybe let's start with the simple stuff, and then we can. I don't want to confuse you. So what this is telling me is there is a node called Turtlesim. We are aware of that. And there is another node with this random name, which is this process and the shell behind the RQT graph. And that this Ros topic is publishing messages on a topic called Total1 command velocity, which is getting subscribed by Turtlesim. Right, so already you can see this is a very good visual tool to do some kind of sanity checks on, essentially that things are working the way you have set them out to be. And it will only show active topics. So, I know there's other topics that Turtlesim is publishing its posts, but right now nobody is subscribing to the post, so it's not shown here. So we'll revisit RQT graph one more time when we launch a different kind of publisher. But I just wanted to make you aware that this is a tool. So you have to run Ros run package name node name to run RQT graph, and so we can exit that. And there'll be many uses of the RQT graph as well. Yeah, just want to make sure it wasn't running in the background. Okay, so now I want to show you another way to interact with the turtle, and for that I'm actually going to kill and stop everything which is running, right? So let's kill this node. Let's kill this command velocity publisher. So you see, as soon as I stop that, it stopped the turtle. Let me also kill the turtle. And I'm actually also going to kill Ros core because I want to show you a better way to organize launching of these nodes. So it almost seems like a fresh start, but this is an opportunity to show another tool called Terminator, like the movie. And so this is a very powerful tool because as you can see, when you work with the Ros nodes, and these different, you have to interact with these different Ros nodes. It can become very messy because you have to launch so many different terminal instances all over the place, and it's difficult to keep track of what your current focus is on, and what terminal is running what. So Terminator kind of fixes that. So, and what you can do is you can install Terminator as a shell basically in Unix, and then you can just split this window into different terminal sessions. You can split it horizontally or vertically. Okay, didn't want to split that. I want to split vertically. And then you can use each one of them as an independent terminal session without having to launch like a million different sessions of your own. So maybe we can even split this horizontal, because the first one I'm going to just say Ros core, and so it's running there. And here I will launch our Turtlesim. So remember how you launch this. It's a node, so we have to use Ros run. Name of the package is Turtlesim, and name of the node is Turtlesim node. So that runs and it spawns here, and let's just keep it here. Then we can earlier we were publishing on Turtlesim using using this Ros Topic Publish. Okay, we don't need that. Let me just get rid of this. So earlier we were publishing on Turtlesim using this Ros Topic Publish and to the command velocity directly. There is another way to interact with the turtle, and so here we will launch our second node now, right? So we haven't yet launched multiple nodes. So here's our opportunity to launch multiple nodes. So I'm going to say Ros run, and the package is still called Turtlesim, but the node I'm going to launch is called turtle underscore teleop key. Okay, so it's that node. And so turtle teleop key is short for teleoperation using the keyboard. And as you can see, this session, by the way, in Terminator, the session which is highlighted in red in my case, so you can play around with the UI colors, is the active session. Okay, so what it is telling me is that as long as this is the active window, I can use the arrow keys on my keyboard to teleoperate and move the turtle. So let me do that. So I'm pressing, arrow keys. Let's see if I can make some symmetric shape. Okay, I missed it. That's okay. So, but you can see you can move the turtle around in like this manual driving mode. And obviously when you move this around, the pose is getting changed, but I want to show you again what is happening underneath the hood, right? How is turtle teleop key interacting with the Turtlesim node itself. So first, let's do our quick introspection. We can say Rosnode List. And just like that, we know that we were just using Turtlesim before. Now we have used another node called teleop turtle, which we just launched in this window right here. And so this makes sense. We have two nodes. So let's inspect this other node, just like we did with Turtlesim. So remember the command is Ros Node Info, and then the name of the node is teleop turtle. And what this is telling me is that teleop turtle is publishing on geometry message twist, which is interesting because who is subscribing to geometry message twist? It's Turtlesim. So this is why teleop key is set up to accept the keyboard input, so it has some scanning process of the arrow keys, and then it uses that information to create the exact packet that we created ourselves with the Ros Topic Publish just a few minutes ago, to create those packets of linear and angular speeds, and then sending it into the command velocity topic, which is getting subscribed to by Turtlesim. Right, so the publication of the Turtlesim is the key here, and in fact we can do the same. We can do the same analysis that we did earlier. So I can say Ros Topic List, and the list hasn't changed because the teleop doesn't create a new topic. It's just publishing on command velocity, which already existed before because Turtlesim was subscribing to this. But now when I say Ros Topic Info about command velocity, total one command velocity, earlier it was missing a subscriber, but now earlier it was missing a publisher, and we knew that Turtlesim was subscribing, but now we know that the teleop keyboard turtle node is publishing on command velocity, right? So you can see this core concept in Ros where things are publishing and subscribing to different topics. But in this case, the teleop key node is the publisher of command velocity, and Turtlesim is the subscriber of command velocity, right? So using, and also I hope you can appreciate how using the terminator is just so much easier way to organize everything, right? So now let's do the same exercise that we did before. We know the name of the topic. Let's echo what messages are being sent on the topic. So we can say Ros topic echo and total one command velocity, and nothing is being published right now, or the echo window is not showing any messages. That's because we aren't moving the total, and therefore this node, which is publishing on the command velocity, will only publish when there are some arrow inputs. So let me go to this window, and when I move the total, you will see we'll have echo messages corresponding to how I'm moving. And yeah, it looks like my virtual machine is acting up a little bit, and the total isn't moving as fast as I want. That's maybe because I'm also running a lot of nodes, but you get the idea. So with that, you have a pretty good idea about how nodes interact with each other on topics, and how the topic itself contains messages of a particular message type. So we saw two types of messages today: the geometry message twist, which is used for command velocity, and we saw a pose message as well, which is something that Turtlesim is publishing as the output. And just to again refresh your memory, we can say very quickly, and you will get into the zone of not having to remember exact commands. So that's why I'm just putting you getting you a feel for how a workflow typically works when you are running things. And we'll get to the development in the main part of the Ros learning. Today is just like a brief introduction. So yeah, you can say Ros topic echo, and we can so I don't have to run Ros topic list every time. Now I just know that Turtlesim is publishing the pose, and the total isn't moving yet, but if the total moves, you can see how the pose is getting updated as well, which is what we anticipate. Right, and then we can also verify what is going on by using one of the tools. We can say Ros run rqt graph, and it will give us this nodal graph, which is exactly what we expect. You have the teleop key node, which is publishing the arrow inputs translated into the geometry twist command message, which is published over the topic total one command velocity, and Turtlesim is listening to that topic and then moving. And as it moves, its own topic, which was published, called the pose, gets updated as well. Right. So so I hope so all of this is coming together. Initially, it could be a little bit overwhelming to see all of that in one go, but that's why I've tried to keep it simple, and we skipped a lot of the stuff that you would find in the handout in terms of the use of services and actions, and we'll get to that later in the course. But for now, I wanted to just like introduce the basic commands of Ros run, Ros node, Ros topic, and Ros message. And we covered some of the commands. There are many others as well that you will discover along the way. And then you even need to remember these commands. I'll show you techniques for using the inbuilt command line manual, where if you've forgotten how to use any command, you can just pull up the manual and figure it out. In fact, why don't I do that right now? So instance, I can say Ros topic, and we can just say help, and it's telling me these are all the different arguments that can follow Ros topic. And so we've already seen a lot of them. We've seen Ros topic hertz, we've seen Ros topic echo, info, list, type, publish. So we've seen almost like 80% of what's possible with Ros topic. But the point is, you don't have to remember all of these. If you have forgotten what features are supported by particular command, just type out Ros topic help, or the command followed by the help, and then Ros will tell you what it accepts. All right, so I'll show you maybe one last thing for the day, and for that I'm going to launch. First, let me just reset the ocean. So let's say Ros service call, and we can just say reset. Okay. So now what I want to do is show you an instance where two nodes can possibly even publish on the same topic, right? So we kind of covered that in the slide. We covered the one-to-many configuration where a single publisher can have many subscribers. But I want to show you the opposite way. So for that, I'm going to relaunch another instance of a node which is publishing. In fact, you've already seen this node before, so we can redo what we just did by saying Ros Topic, let's say publish. I want to publish at a rate of one message per per second. I want to publish on command velocity of message type geometry message twist, and I want to publish an angular rate of 1.8, let's say, and x is 2, and let's run that. And what we expect is what we just did. So our node is running, and here I will create some space to run our RQT graph again. Yeah, and you can see something interesting is happening. Let me make sure this is always visible. So now we have two nodes. We have our teleop node, which is running in this top right session. We have this, the kind of the forced publishing node, which is just publishing one message. And both of them are trying to compete for command velocity in some sense to Turtlesim. So in fact, if I go and move the arrow, interact with the teleop with the arrow keys, see what happens, right? I can interfere with the turtle, and as soon as I let go, it goes back to the command velocity, right? So this is showing us that first of all, you have two nodes which are publishing on the same one, and so Turtlesim doesn't care. It doesn't distinguish, or it doesn't have a preference of one versus the other. It's the order in which things arrive. So maybe because the teleop key node is publishing at a higher rate, I'm able to override the tendency of the turtle to go around in the circle, because we are publishing only at the rate of one message per second, and maybe the teleop key is publishing at a much faster rate. So that's something that you can actually figure out, and I'll leave it as an exercise for you to first figure out which Ros Topic command will tell you the rates at which things are getting published, and then you may want to try this out and figure out why is it that you are able to override the turtle with some. You see here, I was able to, if I just kind of long press the forward arrow, it doesn't even move in the circle at all, but the arrow, the line is not straight. It does deviate a little bit because some messages from this publisher are making it move in a circle, whereas this publisher is asking it to just follow the keyboard commands. So again, you can see the RQT graph shows a very clear picture of what is going on, and which is why it's such a powerful tool to begin with. And maybe I can add one more thing to this. So let's try to even echo, and I think my VM might slow down, but let's see. We can say Ros Topic echo, and I want to echo the pose of the turtle, and let's refresh this. So now you see there is this Ros Topic echo has also created a dummy node which is subscribing to the topic which is being published by Turtlesim in terms of its pose. Right, so we have two publishers sending data to Turtlesim, and Turtlesim is echoing the position of the turtle in the ocean itself, which is getting read by this session of Ros Topic running here. So if I kill this Ros Topic and refresh my RQT graph, you will see this node disappear. Likewise, if I kill the straightforward publisher and refresh this graph, we are back to kind of square one, where we just have two nodes. All right, so I think that should conclude our first lab session, which is essentially more to do with basic ROS commands and some concepts of topics, messages, publishing, and subscribing. What we haven't seen today is, how do you actually write code which publishes to some topics? How do you create topics? How do you create messages? So all of that is queued up over the next couple of weeks, like I said, which will be focused on ROS, and we will switch back and forth between lecture mode and concepts and actually doing some live coding during the lab sessions as well. So I hope this was clear. This was if this was your first ever introduction and opportunity to work with ROS. I hope this was exciting as well, and I will see you in the next lecture, where we will cover some more in-depth details about publishing and subscribing, and then we'll have a lab session corresponding to that as well. So thanks for watching, and I'll see you next time.